Hi, welcome to the I2C Starter Kit. In the Starter Kit you have our I2C to PC adapter, which connects a PC's USB or RS-232 ports to up to 3 I2C buses. The adapter is also able to support SPI and one-wire interfaces, as well as bit bashing the individual ports. An 8-bit I/O port is included. This has LEDs and is based on the NXP PCF8574. The 8574 is an extremely simple I2C chip that only allows you to read and write from its ports. There are no control registers, no configuration. Extremely easy to understand. You get some micromatch connectors and a hub PCB, some micromatch cables, a USB cable and a yellow shipping sheet. The shipping sheet tells you where to download documentation, any drivers that might be required, and our free real-term application to communicate with the I2C to PC adapter. Note that any terminal application or any programming language which can talk to a communications port is able to talk to the I2C to PC adapter. Real-term simply provides you with the fastest and easiest way to test the adapter and get it going interactively. So the first thing to do is download real-term from the I2C chip website. Get the latest version, that's the version with the highest number, in this case 2.0068. It has a simple installer, so install it in the default location on your system. The I2C to PC adapter can be hooked up with the USB connector and connect the 8-bit I/O port to I2C bus number 1. The micromatch connectors we use are a bit unusual in that the indexing is done by a hole in the circuit board, not by the connector itself. So this is pin 1 where the hole in the circuit board is, and the probe on the male goes into the pin 1 hole. So the first thing to do now is start up real-term. I assume you've installed real-term, find its location. There's various options here, but for the starter kit we'll use the real-term. We want to start it with the I2C tab, and we want to communicate using the USB port. Let's get real-term into the picture. Okay, the first thing to notice here is that the CTS light is illuminated. This is a good sign. If CTS isn't illuminated, the adapter is not connected or is on the wrong serial port. Let's press the Get Status button. This returns the status byte from the adapter. So the adapter is now communicating with us and we're in business. We'll just clear the window. So now we want to talk to the 8-bit I/O port. First, for I2C we need to send the I2C start. The letter S sends the I2C start. Then we send the address of the slave. OX40 is the address of the PCF8574. So we'll send 40. And some output data to write to the output. In this case we will write 0F to the output, and we'll send the I2C stop, the letter P. And that's all there is to it. Let's have a quick look at the port itself. When we write zeros, the LEDs come on. So 0F has illuminated the 4 first LEDs on the port. Very, very simple. So let's have a look at this tab a bit more closely. We can set up an address here, which it defaults to address 40. We can read data from the port. We read back 0F. We can write data to the port. Let's write 00 and turn all the LEDs on. Alright. Now you can see that the tab simply sends out the same commands that we can type in the terminal window. There is no difference. Other features we've got available to us are Scan Bus. This is very useful if you want to find a device on the bus. It scans all the 8-bit addresses and returns an N where an address is not acknowledged, and a K for the one location on the bus where there is an acknowledge. So that's the end of the I2C Starter Kit. Thank you for listening.